Alright, in this video we're going to look at the graphs of exponential functions. And to start, first want to just go over how we can tell whether an exponential function will be increasing or decreasing. Or in other words, whether we'll see exponential growth or exponential decay. Alright, so if I have an exponential function, a times b raised to the x power, and our base b is larger than 1, so think about our base, say, equaling 1.25. Well, if that were the case, then I'd be repeatedly multiplying by 1.25, which would in turn be applying a 25% increase to the previous output to get the new output. Okay, so if that base is larger than 1, we're looking at percent increase, which would give rise to this increasing exponential function, whose shape would look like this. The graph is going to get steeper and steeper because the rate of growth is itself increasing. Okay, and so we would get this kind of a shape. Now out here, way off to the left, the graph is going to get infinitely small, and we will have what we call a horizontal asymptote here along the x-axis. Okay, so this is the kind of shape we would see for exponential growth. Now for decay, okay, this is going to look like something like this for the graph, and this will occur when our base b is between 0 and 1. So let's say, for example, the base b is 0.85. Well, as we've seen in a few of the previous videos, that would be really applying a 15% decrease, right? If you multiply an output by 0.85, you're really taking 100% of that output and then peeling off 15% of it to get the 85%. So there you'd be applying percent decreases as you move from output to output. So we would see exponential decay in that instance. And this would be our shape, and again, this x-axis here would be a horizontal asymptote. Okay, so here is picture of our graph f of x equals b to the x, and I can go ahead and slide b around. So right now b is 2.3, and since that's larger than 1, I see this increasing exponential shape like this. And as I make b larger, it's just going to get steeper and steeper. And notice now as I get close to 1, the graph levels out. And at 1 itself, that's really just a constant function, so it's not truly exponential, at least according to the definition our text gives. Now if I go into numbers right between 0 and 1, okay, now I'm looking at exponential decay, right? So if I say have a base of 0.7, that really is applying a 30% decrease from output to output. Okay, so I'm going to get that kind of shape. All right, cool. So now let's go ahead and look at problem number 2 on the worksheet. It says to determine whether the exponential function is increasing or decreasing. And based on what we just said, really all this comes down to is asking, well, is our base larger than 1 or is it between 0 and 1? Okay, so for part A, our base b is 3, which is certainly is certainly greater than 1. So this would be an increasing exponential function. Okay, for part B, we have 4 times 1/3 to the t power. So here our base b is 1/3, and since this is between 0 and 1, this would be a decreasing exponential function. For part C, we have b of n is $15,000 times the quantity 1 plus 0.005, all raised to the 2n. So do be a little bit careful here. Our base is not quite the 1.005, and that's because of the square here. So if I square 1.005, I wind up getting the following value. It's 1.010025. And then I have that raised to the n power. So here our base is a number just above 1. Okay, 1.01, blah, blah, blah. So that is more than 1, so this is an increasing exponential function. But do watch out for that. Because of that square, the base is not just the 1.005. All right, for D, it's 0.894 times the quantity 1 minus 0.005 raised to the t power. So here, our base B is 1 minus the 0.005, which is the same thing as 0.995. And so that's just shy of 1. Right, so our base is between 0 and 1, so that would be a decreasing exponential function. All right, for E, well, be a little careful here. We have 3 to the negative x, so that's really saying 1/3 to the x power. Right, that negative in the exponent is telling you to take a reciprocal. So our base here is 1/3, and that is less than 1. So this would be a decreasing exponential function. And then for F, we now have 1/3 to the negative t. So this negative in the exponent is telling you to take the reciprocal of 1/3. So in other words, you're going to do 3 now, and you're going to raise that to the t. So our base B is 3, which is larger than 1. That's an increasing exponential function. For part G, we have 5/4 times 3/4 to the minus 2w. Okay, so this is going to say take the reciprocal of 3/4, that'd be 4/3, and then you're going to square it. So all together there you have 4/3 squared, which would be 16/9, and then that's being raised to the w power. So our base B here is 16/9, which does exceed 1, so this would be an increasing exponential function. And then finally for H, we have p of x is equal to pi raised to the negative x power. So that negative is going to say take the reciprocal, so 1/pi, raise that to the x, and 1/pi, that's about 1/3.14-ish. Well, that's going to be a number that is less than 1. So we have a base between 0 and 1, so that'd be a decreasing exponential function. All right, and that's going to do it for this problem. Thanks.